quantum computing is the application of the laws of quantum mechanics to computational problems. Now, what I mean by that is our computers are glorified collections of switches. Your phone has a billion switches in it, and depending on which of these are on, which of these are off, you're either writing an email or watching a cat video. With quantum computers, there's something similar, but a bit extra. So the switches in a quantum computer can be on or off, or something in between, kind of on and off at the same time. And this allows quantum computers to tackle problems which our computers at the moment just cannot tackle. Because the idea of having two things, two states, two different ways of being at the same time allows you to tackle two sides of the problem at the same time. From an intuitive perspective. Not all quantum computers work like this, but some do. And if you extend that to not just one switch qubit, but to 1,000, then all of a sudden you can do so many different configurations, so many different problems at the same time, that you've got something which is immensely more powerful and capable than anything we have at the moment. The real answer for why we should use quantum computing is, to be honest, we don't know. But there are some things that we do know. So we do know that there are a couple of problems that quantum computers are very well suited for. Some are good, some are bad. So, for example, if you think about how drugs interact with our bodies, or medicines, how they interact with our bodies, medicines, drugs, they're basically extremely complicated molecules, and they either block some pathways or channels and so on and so forth. How do we come up with new drugs? Trial and error, which takes a lot of time, a lot of practice, a lot of money, a lot of trials, a lot of everything. What if we could design everything from the ground up on a computer? That sounds fantastic. The problem is that to design a drug, you need to solve a very complex molecular problem, which at its heart is a very quantum mechanical problem. And our computers nowadays are simply not well suited for that. They will take decades to come up with anything sensible. A quantum computer can natively solve something like that much quicker. So the idea is, if you had a quantum computer, you'd be able to do things like design drugs from the ground up much more easily. That's one aspect. Another aspect is very, very mathematical. The first proper quantum algorithm which gained notoriety is something called Shor's algorithm, and it allows us to do something called factorization. So take a large number, like 51. 51 is 3 times 17. So you can get the factors of 51, which are 3 and 17. If instead of 51 you have a much larger number, that's a very difficult problem to solve. But quantum computers find that problem easy to solve. And the reality is that this problem underlies a lot of the things that we do day to day, including how we encrypt our information. So actually quantum computers can decrypt information that we're sending to each other over supposedly secure means rather easily. So this is kind of the counterpoint, where quantum computers can actually do things which we might not necessarily want them to do. So from the intersection of quantum and diplomacy obviously has many facets. One of them is, just like artificial intelligence, just like the internet as a whole, there's a technology which has very, very important, groundbreaking, positive applications, but can easily be misused. One could almost call it a dual-use technology in some sense. And how do we govern this, especially when it is not something which is readily available on the market yet? There's still a lot of R&D done. So how collaborative must we be across borders? How do we, who owns the intellectual property rights? Is it private companies that should do this, or is it national research centers? So there's a lot of discussion around the governance aspect of that. So that's one aspect. The other aspect, which is kind of me wearing my, my academic hat, is that there are many aspects of quantum technologies in general. There's quantum computing, quantum communications, quantum sensing, and a couple of others. Many aspects are still being developed, and coming from a small country where we have had some success in this, I firmly believe that many places, no matter how small they are, no matter how long their tradition in science is or not, they will find a niche for themselves in emerging technology. So in our case, it was with quantum communications. Malta is small enough that we can roll out technologies as they are today and stop worrying about improving the technologies, but start worrying about how we bring these technologies to the market. Okay, so it's a different step in the process. So I genuinely believe that each country, each region has a role to play in these technologies, and If you play your cards right and you push the envelope in just the right way, then that gives you a very strong, a very good opportunity to have a strong voice then in the diplomatic, in the governance side of things, which then feeds back onto your diplomacy kind of aspect. So, I see these two aspects where countries should play an active role, both from the academic side and from the diplomatic side. But if you play a very strong role on the academic side, you'll also have a positive effect on your diplomatic outreach, which I think is a wonderful thing. So it's a case-by-case thing. So there are certain things which cost $100 million. There's nothing you can do other than spend $100 million on it. And if your research budget is not that large, you can't justify that. But there are other niches. So again, quantum communications is one aspect where kind of the buy-in is much smaller at the moment. With quantum computing, though, we're starting to see something interesting coming out. So there is the physical aspect of quantum computing, kind of how do we develop quantum computers, the research that goes into that. That is extremely expensive. But now that's starting to kind of be refined to a point where we can start thinking about using these devices more seriously. And that kind of brings with it the question of what do we use them for and how do we use them? And that's kind of the topic of what I would call quantum algorithmics. And quantum algorithmics is, just like most kind of theoretical computer science disciplines, rather a very cost-effective way of entering the quantum technologies market. And there anyone can kind of, with enough time, enough people, enough brain power, can come up with new ideas which could have very, very, very strong, even economic consequences. So yeah, it's a case-by-case thing, but everyone has a role. Quantum diplomacy, or kind of diplomacy around quantum technologies, is still a kind of almost a green field. There isn't very much going on. I mean, the intersection of diplomats with technical people is small. The intersection of diplomats with quantum people is basically negligible. Maybe I'm the only one. So no, there are some activities going on. The first one that comes to mind is something called the Open Quantum Institute, which is led by an organization called JESDA in Geneva, and now headquartered in CERN. Which is quite a poetic way of bringing countries together. And their aim is to tick the box of how do we get quantum resources into the hands of countries that cannot currently afford them. So pool resources and so on. So from the diplomatic perspective, I would say kind of that's the number one activity that's going on. In terms of technology, because at this level of technology, it's very hard to separate the kind of private sector actors from their diplomatic, the diplomatic fallout almost. So if you have an entity like Microsoft, for example, obviously Microsoft is going to have outreach to different governments and so on. So I would regard Microsoft and companies like that as all quasi-diplomatic in this sense. And what we're seeing in quantum technology is that many of the big tech giants have a very, very good, strong investment in these technologies. So there's Amazon, Google, Microsoft, the big tech giants, in quantum computing in particular. And I would not divorce that from the diplomatic. There's a lot of discussions going on at the highest levels. From other aspects of quantum technologies like communication and so on, I think the discussion is much less mature, let's put it this way. So the landscape is still almost greenfield, which is great. I mean, if you want to get into it. I think we're going to start seeing a lot of discussion, both from the kind of dual-use perspective, as I said earlier, with quantum computing, because the implications of having what we would call a general-purpose quantum computer, but a large-scale device that can solve real-world problems. If anyone had access to that, they can break into any communication system. Now, if that anyone is a state actor, that carries with it strong diplomatic repercussions, negative and positive. So that's going to start being part of the big discussion, and I don't think all the questions are answered about that yet, because even at the simple level of diplomats not quite getting just how critical the problem is and just how near term it is. It feels like a problem for the future that may or may not happen, whereas it's going to come up, it's going to sneak up on us. From the quantum communication side of things, there are similar discussions, similar repercussions about how do we roll out such a technology which allows us to communicate in absolute security with one another. and how, what are the uses of that also from a kind of from an international perspective. So the European Union in particular wants to have what is called a European quantum communication infrastructure. It wants every capital to be able to speak to every other capital with absolute secrecy, this ultra-secure quantum communication system. Is that a good thing or a bad thing? I don't know. I would believe it's a good thing, but there is this debate going on. And the counterpoint to that is, what if this technology falls into the wrong hands? Will we have entities or people who can speak to each other so securely that absolutely no one can break into the communication systems ever? Is that a good thing or a bad thing? So again, there's a lot to be discussed there, mostly around the governance side of things, as I'm saying it. But that's just kind of my thoughts, of course. I'm just one person. But I think there's a lot to be discussed over there.